welcome to the lesson 5 on module 1 numerical relaying concept. In this lesson, we will discuss on the basic architecture of numerical relaying, corresponding data acquisition system, the sampling and the how the numerical relay is a combination of hardware and software. This is a picture of numerical relay available in our laboratory. If you see this picture, then this is the front panel, and where we have LED, you can say that lights that shows that those are indicators in case of trip, in case of alarm, and so. Here you can say that in this portion you can see the different values of voltage, currents available, and the relay provides continuous monitoring of the currents, voltage, and the different parameters of the system also, in addition to the during that of the fault process also. Come to this the inside things of a relay, the architecture. So, this is the main processor of the relay, where the corresponding relay algorithm, the principle is being executed. This is a numerical platform. So, it needs, you can say that data samples. For that you can say that the relay needs analog to digital conversion, because the signal is analog in nature, currents or voltages. So, these currents and voltages are sensed to the CTs and PTs, and they are being input, you can say that to the relay. So, this analog input, the analog input is converted to a digital in a digital platform, converted to samples values, and then you can say that the relay can say that processes those samples for a particular decision. Furthermore, the relay can say that take different signals from other relays also in the form of discrete inputs. It can make a decision and communicate to the other, you can say that relays, or to the any to the substation also, to the different communication ports. Its output can be communicated to the circuit breakers which it is connected to. This you can say that the analog input conversions process to the digital form. This you can say that relay, typically processor being, you can say that plus minus 5 or plus minus 10 volt kind of thing. So, therefore, a compatibility issue comes into picture. So, therefore, the corresponding signals, because such a processor takes voltage as the input only. So, therefore, the input signals, currents, voltages must be converted to suitable values, must be scaled down to suitable values compatible to the processors or the hardware architecture of the system. This processor has different memories, random access memory, ROM, PROM and EPROM, to take care the dynamic memory and the permanent memory, you can say that in which the corresponding programs and the data are being stored also. Note that the relay stores several events means faults or disturbances for further processing of the system. So, in broad, the signal processing path in a relay becomes like this. We have CTs and PTs, the corresponding sensors or the transducers, and then you can say that those are being scaled down to the suitable value as compatible to the hardware architecture of the relay. And then we have analog low pass filter, anti-aliasing filters. We will see, you can say that is, you can say that for the efficient processing of the relay that is required. We will address that, you can say that in the later slide. And then we essentially require, you can say that A to D conversion process, so that the digital signals or the samples values of the signal are being held by the processor. And then in the processor, you can say that we have these digital filters, where we can extract like fundamental, harmonics or any transient or any other components relevant to the relay to decide on the fault. And then you can say that so this you can say that is the essentially the software part, where you can say that we program the corresponding principle and embed it inside, and therefore, you can say that algorithm you can say that takes the simplest value of the currents and voltage as required, and then you can say that it calculates the required as per the requirement of the relay, and then you can say that you can say that like in a distance relay, you can say that it computes the magnitude of voltage, current and impedance, and so you can say that and makes the corresponding decision process also. So, as per the requirement of that kind of thing. Now, if you go into details of, you can say that the inside thing of a relay, then we see you can say that here the voltage currents of 3 phases, voltages all these 6 you can say that maybe or more currents may be in a system, or in a differential relay you can think of all you can say that currents from the both primary or secondary side, and like that whatever signals are required for the relay, you can say that those are being input to the systems. We require isolation transformer, you can say that because this is a small signal device, you can say that, and this side you can say that is a large you can say maybe a much higher voltage than the numerical system platform. We require anti-aliasing filters. This is able to pre-filtering in the analog stage of the system. Multiplexer you can say that we require, because we have you can say that several signals to be in the analog to digital processing perspective. So, that is you can say the requirement, and then this is your processor which takes the corresponding signal, and I am say that it requires a different memory, you can say that memory you can say that, or the storage you can say that as per the dynamic processing and permanent storage, and so it has communication cards you can say that to communicate to the outside, and then as already mentioned you can say that it has different inputs, digital inputs, and so to the systems. It can in the output form you can say that it can communicate to other relays, it can provide you can say that informations to the substations, and it can to the LED as an LED information, alarm, and so several things can be you can say that integrated to this output module of the relay. Essentially, it requires you can say that DC power supply for its operational perspective, or you can say that where this DC supply can be from you can say that taken from an AC source and then converted to DC also you can say that for the requirement, or can be from a battery source also. So, broadly you can say that from this picture we can say that a digital relay module or a numerical relay module you can say that consists of the hardware components, and also you can say that software, where the software you can say that the corresponding digital the corresponding algorithm is being embedded. So, this you can say that algorithm nothing but executes the corresponding principle associated with that particular relay. So, if someone is interested or can say that in the factory you can say that the corresponding coding is being done you can say that for the particular task, and so. So, for this you can say that we can say that conventional being can say that digital signal processor or microcontroller, or you can say that today you can say that more and more you can say that improved versions are being also available in terms of the FPGA kit, and so. So, this is you can say that the evolution of you can say that computer technology. So, therefore, you can say that with progress in better and better you can say that technology available in that perspective. So, we see you can say that the corresponding relays numerical relay platform becomes different, and starting from the microprocessor to you can say that to the FPGA kit you can say that you can see variation you can say that in different older versions to the newer version. Now, come to you can say that how the signal you can say that is being managed in the numerical platform. The current signal has to be converted to voltage signal for the as input to the kit. So, the CT you can say that 1 ampere or 5 ampere CT you can say that is connected to a simple you can say way is nothing but connect you can say that different resistances or to the other relays in the series, and then you can say that you take the corresponding output of any one. So, that corresponds to the voltage across this part, you can say that corresponds to the corresponding current proportional to the corresponding current in this path. So, to note, you can say that the CT, you can say that secondary terminal should be connected, you can say that suitably to give the corresponding proportional voltage to the relay. In the PT, or you can say that capacitor, voltage transducer or transformer, you can say that in high voltage system, you can say that the PT signal, you can say that also is much higher, you can say that typically 110 volt or 120 volt phase to phase. So, that has to be considered, again should be downscale, you can say that suitable value compatible to the relay, and therefore, you can say that a simple way is potential divider connection or any other suitable, you can say that mechanism should be there. So, the relay, you can say that as part of the relay, you can say that specification and all these things, the corresponding voltage compatible to the relay should be addressed in this perspective. In addition to that, you can say that from lightning or surge voltages, and so you can say that to protect the systems, the metal oxide varistors MOVs are being considered being considered connected, you can say that in the input side also, and so also in the output, you can say that terminals of the in the analog connectivity to the numerical relay. Now, come to, you can say that the analog, you can say that to digital conversion process, you can say that in this case the sample and hold circuits, what is being done, you can say that see here an example here. Let us say, you can say that an analog to digital conversion process having a, the relay is having a 12 bit ADC in this case, analog to digital conversion process through this ADC. For this, you can say that 12 bits, you can say that, so we can express the 12 bit, you can say that like this, you can say that in this format, you can say that. So, it means, you can say that hexadecimal system, you can say that the largest positive number can be, you can say that 2047, and the smallest negative number minus 2048. So, so these, you can say that the corresponding whatever voltage input, you can say that maximum voltage compatible to that, let us say plus minus 5 volt or plus minus 10 volt. In case of 10 volt, the corresponding plus 10 volt can be, you can say that corresponds to 2047, and the minus 10 volt, you can say that corresponds to minus 2048 in this case. So, in that range, you can say that the corresponding signals, you can say that samples are to be manipulated for effective and efficient, you can say that use of the processor. So, different, you can say that analog to digital conversion principles are there with the evolution of the technology. Earlier versions, if you see successive approximations, flash type is a very fast one. So, there are different ADCs available, you can say that in the different relays. Earlier versions were using successive approximation, flash type is very fast, and today you can say that many relays use sigma delta ADCs also. These, you can say that associated with, you can say that this ADC, there are errors, you can say that creep into the, you can say that to the digital domain in the further computation, and so say you can say that an ADC, you can say that is having plus minus 10 volt 10 volt range, you can say that, and suppose you are using, you say that 12 volt, you can say that a 12 bit ADC, then as already mentioned, you can say that these 10, you can say that divided by 2048 gives, you can say that 4.883, you can say that 10 to the minus 10 3, you can say that volt resolution. So, each, you can say that between 2, you can say that between 2, you can say that data, you can say that which will be acquired by the, you can say that this such a processor, you can say that will be having a, you can say that an accuracy level of 4.833 into 10 to millivolt. So, now you can say that what the, you can say that this processor, you can say that it does in the former, you can say that, let us say you can say that we have a analog input signal, and this is, you can say that straight line is your analog input signal. Then the corresponding, you can say that between, you can say that if you see the step, you can say that perspective. So, anywhere you can say that analog input signal happens to be there, the corresponding, you can say that signal value either, you can say, will be taken at this level or it can be taken into this level, and that results in, you can say that an quantization error called Q equals to the maximum voltage V divided by the corresponding 2 and divided by 2 to the power n minus 1. So, this you can say that the V divided by 2 means, you can say that any sample value can be either taken by this side or that side. So, that you can say that about this process. So, therefore, you can say that this where the n, you can say that is the number of bits, that is in this case 12, and V, you can say that let us say capital V here, you can say that the plus 10. So, that you can say that in this case results in you can say that 2 to the power minus n volt. So, we see you can say that the if you normalize this, you can say that 2 to the power minus n V divided by the V, then the normalized error quantization error becomes 2 to the power minus n. With n, that is number of bits, you can say that in the ADC becomes more and more, the corresponding normalization error decreases. It means that we will be getting more and more better, you can say that sample value for the corresponding analog signal. Now, next you can say that how the sampling is being carried out and what are the corresponding issues we will see. Let us consider a 50 hertz signal, you can say that a sinusoidal signal, voltage, current and so. In this case, we have shown a current signal. Now, this current signal is to be sampled, to be digitized, so that you can say that through the analog to digital conversion process using sample hold circuits and so. So, then we see let us say first you can say that example we see here. Now, we have a sampling of 1 kilohertz, it means that you can say that 1000 samples per second. So, that means that you can say that for a 50 hertz system which is having you can say that 20 millisecond period. So, in that case you can say that the corresponding 1 kilohertz means the corresponding delta t between two consecutive samples, the time interval becomes 1 millisecond. This 50 hertz corresponds to you can say that a time period of you can say that 20 millisecond perspective. Now, let us come to another you can say that situations. We have you can say that only 400 hertz sampling. So, that means that for the 50 hertz system we have you can say that 20 millisecond a period. So, 0.02 second and this 400 hertz corresponds to delta t equals to 0.02 divided by 8 samples. It means that it has you can say that 8 samples in one cycle, and that you can say that time corresponds to between two you can say that consecutive samples 0.0025 second only. So, we have you can say that as compared to the earlier case of 1 kilohertz, we have less number of samples in a cycle or in 1 second or so. So, that you can say that is clearly visible from this you can say that two pictures. Now, come to you can say that higher sampling 3.2 kilohertz, much more than that 1 kilohertz first example. Now, for the same 50 hertz signal and the delta t corresponds to here you can say that 0.02 by 64. We have you can say that 64 samples per cycle, that implies here. So, you see here you can say that the number of samples in one cycle becomes much higher, and that this clearly visible that if you like to have you can say there are more details of the signal, we should prefer higher and higher sampling rate for the relay. So, this is what you can say that we say that typically today's relays you can say that takes you can say that at a sampling rate of you can say that 1 kilohertz and above as high as you can say that 8 to 10 kilohertz you can say that sampling rate perspective. Now, the issue with the sampling is see here you can say that suppose this is the same you can say that 50 hertz signal, and as per the Shannon sampling you can say that the 50 hertz signal should be at least sampled by twice of the frequency you can say that for the fundamental component that is 100 hertz. If you sample at 100 hertz you can say that for this one, and if you start from this point you can say that you will be sampling at 100 hertz. So, every you can say that half a cycle will be getting 1 point, and that leads to you can say that situation of only is these values will be obtained you can say that in the analog to digital process. It means that from this value you cannot interpret the corresponding signal of 50 hertz. So, that leads to you can say that aliasing issue you can say that to the for the processing systems. Another issue related to that you can say that let us you can say that the fundamental signal is you can say that the green one, and the red one you can say that is a contaminated you can say that signal of this 50 hertz component contaminated by fifth harmonic with a 30% fifth harmonic to the fundamental. So, this is the let us say assume that this is the signal available to the relay in a typical distribution system or so in the current. Now, then you can say that if the relay acquires you can say that signals at a sampling rate of 400 hertz, it means that 0.02 by 8 second, then the corresponding samples value which will be acquiring you can say that will be like this. From the samples value if you see you can say that whatever you can say that further processing will be accomplished, because these samples values are you can say that either lower or higher you can say that than the corresponding samples value of the green signal, that is the fundamental signal. So, the corresponding computation process you can say that, and the will be considered affected by those you can say that erroneous samples in this perspective, and that is what the aliasing issue with higher sampling you can say that high frequency components available in the system. So, to overcome this and anti-aliasing filters are being used, and typically what they do is that they filter out the high frequency component you can say that from the signal before you can say that the analog to digital processing is being carried out. So, that is what you can say that the compatibility, what is the corresponding sampling rate of the ADC, and then you can say that what is the signal frequency of interest to the relay for the further processing perspective. Accordingly, you can say that the suitable you can say that such you can say that aliasing filter you can say that is being put before the analog to digital processor. So, this is a low pass filter, and then you can say that if the low pass filter cutoff frequency is f c, x axis being frequency and y axis being gain of the you can say that filter. So, an RC filter you can say that may be adequate for this case. So, older version of relays you can say that we are using you can say that multiple stages of RC filters for effective things. However, you can say that more and more stages of RC filter means delay in the acquisition process becomes higher and higher. And today you can say that we have op-amp based you can say that active filters are being there also to accomplish these tasks of anti-aliasing filtering perspective. Typically, a relay specifications have n number of numerous you can say that things are there you can say that. For example, you can say that we have for a typical relay you can say that 1 kilohertz to 8 kilohertz sampling rate, a very good you can say that relay may be 8 kilohertz very powerful relay you can say sampling perspective. It may be 32 bit, but older relays you can see that 8 bit and so also you can say that. So, with more and more powerful relays and cost being lesser and lesser, you can say that we will find number of bits to be higher and higher you can say that in the ADC process and so. In addition to that, the relay requires data storage and so therefore, you can say that that is what an important aspect of the relay. So, data recording you can say that each day for each fault event you can say that the relay stores you can say that data, and it can store you can say that several such events in its unit. So, that you can say that typical that also is being specified by you can say that the manufacturer. The power supply to the relay it can be considered from the both the DC and AC as available. So, these were something like in a specific relay 48 to 125 volt DC or 110 to 120 volt AC supply can be good enough for a that relay, both it is compatible to both. Then you can say that the burden you can say that from the this side is not only 35 watt, or you can say that from the DC side you can say that, and less than you can say that 90 volt ampere for the AC you can say that voltage perspective. The AC voltage inputs which the relay can support you can say that for this case 3 phase for example 3 phase 4 wire input you can say that, and the rated volt you can say that can be from 0 to 300 volt you can say that line to line. It means that the corresponding voltages are again being considered scaled down to suitable value before the analog to digital process is to be carried out. And the burden you can say that is much smaller as compared to the earlier version of analog, or you can say that analog relays and all these things, only 0.1 volt ampere for the 125 volt input or so. Similarly, the AC currents you can say that the secondary of the CT you can say that can be 1 ampere, can be 5 ampere for the same relay, and in case of 1 ampere you can say that the maximum current you can say that matching to that relay is 18.2 ampere. For a 5 ampere it becomes 91 ampere. This is an example for a typical relay. The burden rating for the CT you can say that is also pretty low, you can say that 0.1 volt ampere you can say that for 1 ampere you can say that things, and 0.5 volt ampere for 5 ampere you can say that. So, this you can say that shows you can say that some of the technical specification of a typical relay perspective. Now, come to the consider the software you can say that domain where the numerical relay executes the corresponding algorithm. So, it reads the corresponding voltage and samples all 3 phases or single phase or whatever as per the requirement of the relay, and then you can say that it accomplishes the corresponding digital filtering part. In the digital filtering there can be several steps you can say that, including corresponding process of, you can say that, of the different discarding the different unwanted component and finding out, you can say that, the corresponding next finding out the computing the corresponding phasor component, that is fundamental component, or required harmonics and so like in a transformer protection. And then you can say that after availing all the, you can say that, different components of the signal, the relay goes for the, you can say that, applying its principle on the protection method, like you can say that overcurrent principle, differential principle, or you can say that distance relay and so. So, then in that protection methods, it finds, you can say that, whether the fault is inside the zone or so, and if it is so, you can say that it provides the trip signal to the circuit breaker for tripping, or it can communicate to the other relays and substation perspective and so. And in case of, you can say that, the corresponding the relay, you can say that if it is a no case, then it can, you can say that, go on, you can say that, continuous reading of those, you can say that, samples, or it can also modify the corresponding settings of the, you can say that, perspective depending upon the system condition and so in the form of an adaptive relay and so. Now, come to, you can say that, how the corresponding sample values are being useful in the relay process and so, you can say that, before going to the more details in further in subsequent lectures and so, let us, you can say that, see. So, this you can say that, and current signal, and you can say that at this point, you can say that fault inception has occurred, you can say that, and the fault, you can say that, and after that you can say that the corresponding signal current signal jumps, you can say that, to a higher value. So, you see here, you can say that these samples values are being acquired through an analog to digital process or ADC, and once these samples values are there in the, you can say that, to the relay, in the software, you can say that principle the relay executes the different algorithms. So, here you can say that, see here, if we see this is a fault detection process only to know that whether the fault is there or not, and after that you can say that the relay can do the sophisticated algorithm for a decision whether the fault is inside the zone or it is beyond the zone and so. So, this is a very simple step, you can say that, and very widely you can say use many of the relays, you can say that, to trigger the event fault event and so. So, here the fault is incepted, and then you can say that if you see the next sample, the corresponding jump in current is very large, whereas you can say that in this between two consecutive samples, in this case before the fault, the corresponding sample the current change, you can say that, is smaller. That you can say that going to that principle, you can say that, call a sample to sample comparison. If you go, you can say that, then the I n minus I n minus 1, where n corresponds to the present sample value minus the, you can say, just the earlier sample value, then you subtract the and take the absolute value, you can say that, you say that, you can say that during the fault, you can say that this change is much significant as compared to the pre-fault case. So, therefore, whenever you can say that this change is significant, you can use a threshold for the suitable threshold for the purpose. Whenever this corresponding change becomes significant, you declare the relay declares that this is a fault situation, and then accordingly you can say that further activities can be carried out. Similarly, you can say that we know that in a typical power system, let us say 50 hertz signal, this is the current. So, the it maintains its periodicity. So, between, you can say that current sample and one cycle ideal sample, this would be same in general in a normal situation. So, that leads to, you can say that this the I n minus I n minus n, where capital N here corresponds to one cycle, you can say that, of period. So, in one cycle period earlier you can say value, this you can say the difference should be 0 or very near to 0. Whereas, in case of it goes to the consider fault inception at this point, then the consider this corresponding point one cycle earlier point, then the corresponding difference between the point in the fault region and fault in the point in the pre-fault region, this you can say that difference you can say that will be much higher. So, if the corresponding you can say that detection process uses, you can say that this one cycle the cycle to cycle comparison of the samples and finds the absolute value, and then you can say that we say that normally it should be 0 or very close to, near to 0, and whenever it enters into the fault region, this value will be significantly high. So, so this also you can say that can be used, you can say that the fault detection process. Now, if we compare these two, you can say that fault detection principle, simple principle, sample to sample and the cycle to cycle. So, whenever you can say that a fault has happened, you can say that this is the current signal, you can say that in a fault situation, the corresponding sample to sample rises and again like this, and so also the cycle to cycle process rises. Note that you can say that such you can say that principle is useful only to trigger, you can say that in the initial following the inception of the fault as fast as possible. So, these kind of simple you can say that principles can be used, you can say that effectively successfully for fault detection process. What we demonstrated here, you can say that is that how these samples values are being used in the relay. In the subsequent class in the lectures, you can say that will how you can say that these samples are further processed for different other computations and effectively used, that we like to see. Note that the relay, you can say that computes the corresponding the relay acquires a new samples and computes the such fault detection process, but in between you can say that it computes, you can say that the further things and uses its digital filtering, the filtering you can say that algorithms and the corresponding principles which it uses, and then you can say that makes a decision before the new fresh samples is being acquired in the process. So, in the next lesson we will discuss about phasor estimations technique. Thank you.